Hi everyone, today we are going to discuss about the topic carboxylic acids. Everyone knows that in organic chemistry, the organic compounds are known by their functional groups. There are many functional groups are there. Among them, if you talk about the carboxylic acid, this functional group is a COOH. Okay, COOH. So this is a functional group. By this functional group, we can identify carboxylic acids. And here in carboxylic acid, in this functional group, you can see two types of that is carbonyl group, as well as you can also see the OH group. The carbonyl group, this is nothing but it is a carbonyl group, and this is nothing but this is a hydroxyl group. So carbonyl group as well as the hydroxyl group. So collectively by combining these two, we can get the name that is a carboxylic. And of course the nature of these compounds are acidic in nature, so that's why we are using a word, that is we are adding a word that is acids. So these are called as a carboxylic acids, and these carboxylic acids are represented by general formula that is R C double bond O OH. So this is a general representation of a carboxylic acid. Now what do you mean by R? R is nothing but either it is a aliphatic compound or these are aromatic compounds. So again the carboxylic acids are classified into aromatic compounds as well as the aliphatic compounds. Now what are the aliphatic compounds? So these are the saturated hydrocarbon chain. Saturated hydrocarbon chain, either it is like a methyl group or it may be any alkyl group, like you can take methyl or ethyl group or any propyl group. You can take CH2, CH3, like it is a saturated hydrocarbon chain, alkyl chain, any alkyl chain. For example, you take one simple example I am writing, that is a CH3COOH. Okay, so these are called as a acetic acid. This is a acetic acid, or we can also call as a ethanoic acid. And here the CH3 is nothing but it is a alkyl group. Okay, the alkyl group may be a methyl, or alkyl group may be a ethyl or propyl, or any chain you can take. Now talking about the another aromatic is nothing but the R group will be simply replaced by that is a benzene ring, and to this we are writing as a COH. So this is a simple example of benzoic acid. So what we are calling this as this is a benzoic acid. So like this carboxylic acids are classified into two types, that is aliphatic, that is either you are having any alkyl chain, or aromatic, either it may be having a benzene or naphthalene or phenanthrene, anything you can take. So like this is a brief introduction about the carboxylic acid. Now we will move on to the next topic, that is a preparation, because the preparation will going to play a very important role. Now let us talk about the preparation of carboxylic acid. So in this topic especially I am in this topic I am especially focusing on aliphatic carboxylic acids, how to make a aliphatic or saturated carboxylic acid. Now let us see first preparation, that is first preparation by preparation of carboxylic acids by using a method that is alkyl nitriles. So by using alkyl nitriles, or by using amides, or by using esters, we can prepare the carboxylic acids. So first what I have written here, that is the preparation of carboxylic acid by using alkyl nitriles. Now let us see what do you mean by this alkyl, what I am writing, alkyl nitrile. So alkyl nitrile is nothing but Alkyl means here I am writing a R, and the nitrile will be written as a CN, that is cyano group. So these are called as a alkyl nitrile. And this alkyl nitrile, when we are subjected to the hydrolysis, okay, when we are subjected to the hydrolysis, then we can get that is carboxylic acid. So this is the conversion of alkyl nitriles. Alkyl nitriles are converted into a carboxylic acid in acidic medium. Okay, either you can take acidic medium or we can also go for a basic medium. So first we can write another one simple example. I am taking, that is a CH3, C triple bond N, and by hydrolysis we are going to get, that is CH3 COOH. Now let's see the mechanism, how we are going to write. So what I am doing, so here I am taking, that is R, that is C triple bond N, and as we know that apart from 3 bonds, so you are having a lone pair of electrons on nitrogen. So nitrogen is also having a lone pair of electrons. Now in acidic medium, when you are adding a dilute acids, what happens here? So these are the lone pair of electrons. This will going to attack the proton which is coming from the acid. Now what happened? That leads to the formation of C triple bond N H, and on the nitrogen you can see the positive charge. Now you will ask me why the positive charge has arrived, because this hydrogen, this is a H plus, okay, this proton, this is not having an electron and it is donating its electron pair to H plus. So that's why this nitrogen is acquiring positive charge. Now what happens here? The water molecule will going to come here. So how to write the water molecule? As we know, the formula of water is H2O, and on the oxygen you can see 2 lone pair of electrons, that is 1 lone pair and this is another lone pair. What are lone pairs? The electrons, these are nothing but a non-bonding electrons which are not participating in bond formation. Now here what happens? Because of the presence of extra electrons, this oxygen is acting as a nucleophile. Okay, I'm going to repeat once again. Here you can see the hydrogen and oxygen, and on the oxygen you can see the lone pair of electrons are there. And because of this is acting as a nucleophile and this will going to attack this carbon. Then you people will going to definitely ask me the question, why madam this lone pair of electrons are attacking this carbon? Because already the carbon is attached to the nitrogen, that is electronegative atom. Because of that it becomes an electron deficient. Okay, already positive charge is there, so it has become more deficient, electron deficient, and here this carbon will be acting as a electrophile. Okay, so here hope you're understanding properly. See here these are the lone pair of electrons. Okay, these are attacking directly to the carbon. Yeah, so that leads to the formation of what? Now here we can write the structure R C, that is double bond N H, okay, and here the O H and H. 1 lone pair of electron already donated to this, so that's why it will going to get the positive charge. The oxygen, the electron pair will be donated to this, that's why the oxygen get the positive charge. So it is donated, and here you can see this is donated electron pair to this electron deficient carbon, and this is acquiring the positive charge. As it is donating, and these 2 electrons will be given to the deficient nitrogen. Therefore, you can get the lone pair electrons back. Is it clear? Now what happens, children, here? Now simply to remove this, what happens again? These 2 electrons will be going, and here you can write COH as I am writing the 2 electrons, double bond NH with this. Now what happens here? Again the H plus will going to attack, because again the lone pair of electrons are there. So what happens here? R C double bond N H, again H, again the positive charge will going to come, and here the OH. Now what happens here? This electrons are moving here, and we have to remove the positive charge, and this leads to the formation of RC double bond O, and this is nothing but a NH2. This is nothing but it is a amide. So this is the way what we are preparing our amide. So I will tell you slowly. So what exactly happens here? We have taken the nitrile first stage, you can see. So first the lone pair of electrons will be attacking the H plus, and this leads to the formation of positive charge on the nitrogen. Again the water molecule will be coming, and this water molecule will be donating its electron pair to the electron deficient carbon. Now by this donation, the oxygen will going to acquire the positive charge, and you can see again that is the lone pair of electrons will be attacking the proton, and that leads to the formation of. Now what I want to tell you that you are going to get the amide here, and this on further hydrolysis, then this leads to the, here you can see the OH will be coming here, and the NH3 will be removing. So I don't want to write much more steps here. C double bond OH, simply remember, children, that OH will be coming here and H will be removed, and the byproduct will be the ammonia. So the simple way, first you understand how to write the product. Writing a product is very important, and understanding a mechanism is also very important. So what we have learned in this topic today, how to prepare carboxylic acid by using alkyl nitriles. So alkyl nitriles, we are taking this alkyl nitrile. By using alkyl nitrile, we can convert into carboxylic acid. So either it is in what, acidic condition, or either it is in basic condition.